Alright, welcome back to another episode of Math with Mr. Young. So today we're going to work with 6.2 solving equations using addition or subtraction. Our standard is 6th grade evaluating expressions A, and our objective today is that we're going to be able to write and solve equations using addition and subtraction. Our mathematical literacy, we have inverse operations and solution. Alright, with 6.2 solving equations using addition or subtraction, our success criteria is that we're going to determine whether a value is a solution of an equation. We're also going to apply the addition and subtraction properties of equality to generate equivalent equations. We're also going to solve equations using addition or subtraction. And also, we're going to create equations involving addition or subtraction to solve real-life problems. Very important, we have our mathematical literacy. This is essential in understanding the mathematical language. So today we have solution and inverse operation. So let me explain to you guys what a inverse operation is. So an inverse operation, this is the operation that reverses the effect of another operation. Think of opposites. For an example, we have addition and subtraction, and these two are opposites of each other. And we also have multiplication and division. These are also opposites of each other. Okay, it's kind of like a yin-yang, day and night, bad and good. Everything has an opposite to it. So with that being said, remember it reverses the effect of another operation. So if I were to add something, let's say if I were to add 2 to something, to undo that, I would subtract 2. Okay, so with that being said, let's talk about a solution. Okay, keep this in mind so this makes more sense. So a solution, this is a value or values that we can put in place of a variable, and a variable could be any alphabet or any letter from A through Z. The whole thing to make a solution is it makes the equation true. So for an example, let's tie this in together now. You have x plus 2 equals 7. Now it has to equal 7. So if we're adding 2 to whatever the value of x is, it has to equal 7. So in this case, we're going to use the inverse operation of addition. So the inverse operation of addition, it's going to be subtraction. So if we have 7 take away 2, we have 5. So that would mean that x equals 5. And if we substitute 5 for x and add that to 2, 5 plus 2 equals 7. So that would mean that if x equals 5, then this would be a solution. So this is a solution to the equation. Okay. So we have to make this true. So 5 plus 2 equals 7. That is true. And if x equals 5, then that makes this equation true. So x equals 5 would be the solution. All right. Again, we use inverse operations to solve that one. The opposite of addition, subtraction, and we subtracted and found the value of x, substituted and added. And remember, they have to be equivalent on both sides to be true. All right, so for this example, I don't know if you guys know what a teeter-totter is, but I'm going to put a triangle in the middle, and it's kind of like a balance scale. Let's see here. Move that out of the way. Okay, so I'm not the best artist. Some of you guys probably are way better artists than me. So I'm still at stick figures here. So let's say that these two people here are exactly 100 pounds each. And this is a perfect balance. So, it's balanced. So that's what the equal sign means. So the equal sign. So that's kind of what we're going to do here. But the equation, just remember that an expression is has no equal sign. But to make it an equation, the expression has to have an equal sign. And we do have a total there. Okay. So in this case, For the first column, we have the value of x and a list of numbers. The second column, we have the equation x plus 3 equals 7. And then we want to know, are they, on both sides, are they equal? So we want to know if they're a solution or not. So basically it's like this. So if x equals 3, and if we were to write the equation and substitute 3 for x, and of course it has to equal 7, so 3 plus 3 equals 6. So basically 6 is not equal to 7. So again, the question is, are both sides equal? For this one, we're going to say no. So if x equals 3, 3 is not a solution for this equation because it doesn't make it true. And if you notice, I put a slash through the equal sign. That basically tells us in math that 6 is not equal to 7. Okay, let's do it again. This time we have the value of x. This time it's 4. So if x equals 4, and we substitute that in the equation, x plus 3 equals 7, and substitute x or 4 for x, okay, and then 4 plus 3 equals 7, and 7 is equivalent to 7, so it checks because that makes it true. Then are they equal on both sides? Yes, they are equal on both sides. So if x equals 4, then 4 would be the solution to make this equation true. Okay, we're perfectly balanced there. For this one, the first one, that teeter-totter was basically oops, the other way, because 7's heavier. Okay, there you go. And for the last one, if x equals 5, and we have the equation x plus 3 equals 7, we substitute 5 for x. 5 plus 3 equals 8, and 8 is not equivalent to 7, so are both sides equal? No. So 5 would not be a solution to make that equation true. Okay, so that teeter-totter will look like this because 8 is heavier than 7. All right, so we want to keep them perfectly balanced. And of course, we're looking for solutions. To continue, we're going to continue with more examples. So we're going to check solutions here to see whether or not these statements are going to be true. So the directions tell us, tell whether the given value is a solution of the equation. So the equation for A, we have 4 different examples here, is p plus 10 equals 38. But it gives us a value for p, the variable. So p equals 18. Now, if p equals 18, we substitute 18 for p, and we add 18 plus 10 is going to be 28, and 28 is not equivalent to 38. So both sides of the equation are not equal. So what that means is, so if p equals 18, it is not a solution. Okay, let's try the second one for B. Again, this is a different equation. 4y equals 56. And remember that we're given a value, and this value is y equals 14. So if we were to substitute 14 for y, it should equal 56, or it might not equal 56. 4 times 14, oops, let's go ahead and write 14 here, times 4. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. So this will be 56, and 56 is equivalent to 56. So that would make that true. So y equals 14 is a solution. Okay. Now let's look at C here. This one we have a plus 6 is equals 17 when a equals 9. Okay, so if we substitute 9 for a and add that to 6, we want to know if it equals 17 or not. And 9 plus 6 equals 15, and 15 is not equivalent to 17. So if a equals 9, it is not a solution because they are not equivalent. They are not the same value on either side of that equation. Okay. Now for the last one, D, 9 minus G equals 5. So that is if G equals 3. So if we substitute 3 for G, 9 take away 3, we will see that 9 take away 3 is going to be 6, and 6 is not equal to 5. So if G equals 3, it is not a solution because they are both not equal on both sides of the equation. All right? So hopefully you guys are understanding this, and let's continue. I want to talk to you guys about the addition property of equality and the subtraction property of equality. So let's focus on the addition property of equality. Again, they are the same concept, so let's just pay attention. So for the addition property of equality, when you add the same number to each side of the equation, the two sides remain equal. So numerically, if we have 8 here, 8 should still equal 8. Okay. Now if we add 5 on both sides of the equation, 8 plus 5 equals 13. And 8 plus 5, 8 plus 5 equals 13. So they're both equivalent. Okay, so that would make that statement true. Now algebraically, and algebraically means basically it's still a expression, but we have unknown variables or unknown values represented by variables. So if we have x minus 4 equaling 5, okay, so if we were to try to isolate the variable x, we're going to do the inverse operation of subtraction, which is addition. So to get x by itself, we're going to have to add 4 on both sides. Negative 4 plus 4 is going to be 0, and x is by itself. And 5 plus 4 is going to be 9. Okay, so that would make that statement true. Again, this is the addition property of equality. We're adding the same number to both sides of the equation so that both sides remain equal. Okay. Now for this one, because if you think about it, right here, let's check this real quick before I move on. So if I substitute, let me rewrite the equation, x minus 4 equals 5. So if x equals 9, I'm going to substitute 9 for x. 9 take away 4 is 5, and 5 is equivalent to 5, so that is true if x equals 9. Okay, so hopefully this is making sense to you. Now the opposite of addition is subtraction, so the same thing. Now when I mention numerically, I mean with numbers. So if I have, let's say, again, 8 is equivalent to 8, but instead of adding 5 to each side, if I subtract 5 on both sides, 8 take away 5 is 3, so I'm still going to have the same value numerically. But algebraically, if I have, again, the opposite of subtraction is addition, so x plus 4 equals 5. So instead of adding 4 on both sides of the equation, here's the equation on both sides. To isolate that x value, I'm going to subtract 4 from both sides. Okay, so if I have 4 and I subtract 4, I have nothing, and x is by itself, and 5 take away 4 is going to be 1. Okay, so x equals 1. So to check this, I'm going to rewrite the original equation, x plus 4 equals 5, and substitute. If x equals 1, I substitute 1 for x, into the equation, 1 plus 4 equals 5, and 5 is equivalent to 5, so that checks, that makes that true. So if x equals 1, then that is the solution to this equation. Okay? And those, my friends, are the addition and subtraction properties of equality. Basically, remember to add the same number to both sides of the equation, no matter if you're subtracting or adding. All right, to continue, we're going to solve equations using addition. Now, basically, we're going to look for solutions using inverse operations for these next 3 example problems, and then we're going to check them. Okay, where we substitute and solve or evaluate. Okay, so we have A, B, and C. So let's work with A first. So we're going to solve x minus 2, and that should equal 6. Now again, remember that we're going to use the inverse operation of subtraction and reverse this. So if we have the inverse operation of subtraction is going to be addition. So we're going to have to add, since this is minus 2, we're going to have to add 2 to each side of the equation. Now, negative 2 plus 2 is 0. Okay, so if we have like a number line here, okay, here's 0, here's negative 1, here's negative 2. So if we're at negative 2 and we add 2, we're going to add 1 and add 1 more. So we're going to be at 0. Okay, so again, negative 2 plus 2 is 0. So these kind of cancel out, and x is by itself. And 2 plus 6 is going to be 8. So we're saying that the solution is x equaling 8. Okay. Now we're going to check this by rewriting the original equation, x minus 2 equals 6. And if we substitute 8 for x into the equation, 8 minus 2 equals 6, and 6 is equivalent to 6, so this checks. So x equaling 8 is a solution. All right. So that's basically what we do, and we're going to do the same thing to the next problem. So the next one we have, and just pay attention again, we're going to solve, we're going to evaluate when the equation states that the total is 18 when we add, or when we have x minus 7. So again, we're going to do the inverse operation of subtraction. The inverse operation of subtraction is addition, because addition reverses the operation of subtraction. So we want to isolate the x variable. So we do that by adding 7 to each side of the equation. Okay. Now, if we have negative 7 plus 7, just like what I mentioned before, okay, 0. And if we have like negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7, if we're here and we add 7, we're going to have 1, 2, 3, 4, 5, 6, 7. Again, we're going to be at 0. So again, negative 7 plus 7 is going to be nothing, so this cancels out. So we're going to be left with the variable x. Now 8 plus 7 is going to be 15, carry your 1, and then 1 plus 1 is 2. So we're going to say that the x value is going to equal 25. Now to make this, to see if this is a solution, if x equals 25, we're going to rewrite the original equation. 18 equals x minus 7, and we're going to substitute 25 for x. 25 minus 7, it should equal 18. So again, I'll just stack it. 25 take away 7, so we're going to have to borrow from the tens place. This becomes 15. So this will be let's see here, 8 and then 1. So again, 18 is equivalent to 18, so that checks. So that means if x equals 25, that is a solution to the equation. Okay. All right, the last example. So we're going to solve k minus 3 equals 1. Now again, we're going to isolate the variable k. So to do that, so we have minus 3 here. Now we're going to have to isolate it by subtracting or adding 3 to both sides, because addition is the inverse operation of subtraction. So negative 3 plus 3 is going to be 0. So k is going to be by itself. And 1 plus 3 is 4. So we're saying that, or conjecture, our conjecture is that we're going to hypothesize, but in math, hypothesizing in math is called a conjecture. So we're saying that we're saying that 4 is or k equals 4, and that's a solution. So to check this, we're going to rewrite the original problem, the equation k minus 3 equals 1, and we're going to substitute 4 for k. So 4 take away 3 is 1, and 1 is equivalent to 1. So that checks. Okay, that makes it true. So when k equals 4, that is a solution to the equation. Okay. All right. With this next example, it's basically the same thing. Before we were we were solving equations using addition. So we were adding that value on both sides of the equation. This time, using the inverse operation, we're going to be subtracting from both sides of the equation. So again, with these three problems, let's solve the first one for a. So the equation says x plus 2 equals 9. Again, we're going to solve for this. So if we have a plus 2, we're going to do the inverse operation, which is subtraction. We're going to subtract 2 from each side of the equation. Okay, 2 take away 2 is going to be 0, and we're left with x by itself. 9 minus 2 is going to be 7. So we're saying that our conjecture is x equals 7. We're saying that that is a solution. Now to check it, we're going to have to rewrite the equation. X plus 2 equals 9. Okay, and then substitute 7 for x. So 7, we're going to substitute that for x and put that into the equation. And 7 plus 2 does equal 9. So 9 is equivalent to 9, and that checks. So when x equals 7, this is a solution to the equation that makes it true. All right, we're going to continue with the next example. So for b, we're going to solve now. So this time the algebraic equation tells us that we have 26 is equivalent to x, or 11 plus x. Okay, so for this one, again, we're going to be solving equations using subtraction. So what we're going to do is we're going to subtract 11 from both sides of the equation. Whoops. Okay, so 11 take away 11 is 0, and we're left with x. Now 26 minus 11 is going to be 6 take away 1 is 5, 2 take away 1 is 1. Now we're saying that 15 equals x. That's our conjecture, okay, or hypothesis mathematically. Now to check this and solve, we're going to have to rewrite the original equation. 26 equals 11 plus x. And what we're going to do is we're going to have to substitute 15 for x. So substitute 15 for x into the equation. Now 15 plus 11 is going to be 26, and 26 is equivalent to 26, and that checks. So when x equals 15, this is a solution to the equation that makes it true. All right, and the last one, we're going to solve again. This time we have s, the letter s plus 8 is going to be equaling to 17. Now we're gonna go ahead and subtract, because that's the inverse operation of addition, and we're gonna subtract 8 from each side. Okay. Now 8 minus 8 is gonna be 0, and we're left with s. These kind of cancel out. Okay. And 17 minus 8 is gonna be 9. So our conjecture is that we're gonna have s equaling 9. Now to check this, okay, we're going to rewrite the original equation. S plus 8 equals 17. And we're going to substitute 9 for S. And 9 plus 8 will equal 17. And 17 is equivalent to 17. So that checks. That is true. So when S equals 9, that makes this a solution. That makes the equation true. Alright, that's really all there is to it, guys. Alright, the last one, we have a word problem, and this one we're going to model real life. So we're going to imagine here, you being in this situation and insert yourself into this situation. So your aunt gives you $50 to buy the telescope that you always wanted, okay? And after you buy the telescope, you have $25.50 left over. So what we want to know is how much money did you have before your aunt gave you $50? What we're going to do, let's see here. Let S be the starting amount. We do know that your aunt gave you $50. Okay. You have $25.50 left. Okay. So how we will solve this is basically, let's see here, we minused an amount here. Let's see here. All right, so let's pretend that the telescope that you wanted, cost you $275.95. That was a missing piece. Okay, so we're gonna subtract that from the amount, $275.95, and then we were left with $25.50. Okay. All right, so now we're gonna solve this and try to figure out the starting amount that we had. So what we're gonna do is we're gonna add $275.95 on each side of the equation. Okay, so negative $275.95 plus $275.95 is 0. Now we're going to add that on this side. Okay, 0 plus 5 is 5. 9 plus 5 is going to be 14. Okay, 10, 11. Okay, 7, 8, 9, 10, and then 3. Then 1, 2, 1, 2. So this is going to be $301.45. So then we're going to rewrite the equation. S, bring this all down. S plus 50 equals 301.45. Okay, that's where we're at. And then again, we're going to have to isolate the variable. We want to get that variable by itself. So again, we have 50 here. We got to get rid of that 50. To do that, we use the inverse operation of addition, which is subtraction, and subtract on both sides. Okay, 50 take away 50 is 0, and then we're left with S, and of course, $301.45 take away $50. This is going to be 5 take away 0 is going to be 5. 4 take away 0 is going to be 4. 1 take away 0 is going to be 1. And then 30 take away 5 is going to be 25. Okay, so we're saying that S equals $251.45. That's our conjecture. So now we're going to check. So we're going to check now. S plus 50 minus $275.95 should equal $25.50. Now when we plug this in for S, we're going to have $251.45 plus 50. We're going to plus 50. Okay, so this is going to be 5, 4, 1, 10, and 3. So that kind of matches that. All right, and then we're going to subtract $275.95. 5 take away 5 is 0, and this should equal $25.50, by the way. We're gonna borrow here. This is gonna be 4, so or 14, I mean. So 14 take away 9 is gonna be 5. Okay, and then we have 300 take away 275. We're left with 25. So $25.50 matches $25.50. So that checks. So when S equals $251.45, that makes the solution for the equation true. All right. So if you notice that instead of writing it horizontally, that can kind of like get in the way. And if you notice, I started stacking them vertically. You could do that if you want to. It's really your preference. And it's basically the same thing. It's exactly the same thing of what we worked on over here when we solved equations adding or using addition and solving equations using subtraction. But we just combined it in a real life situation. All right. So that's basically it, guys. And this is 6.2, solving equations using addition or subtraction. So by now you should be able to determine whether a value is a solution of an equation. You should also be able to apply the addition and subtraction properties of equality to generate equivalent equations. And you should also be able to solve equations using addition or subtraction, and also to create equations involving addition or subtraction to solve real life problems. All right, so we'll do some more example problems as we go. And again, I do want you guys to pay attention and have fun with it, guys. Have fun with mathematics, and make sure you turn in your missing assignments for all of your courses and catch up. Those grades can be changed, but ultimately it's out of my hands, it's in your hands, and you have the power to change your grades. All right, so we'll see you guys in a bit, and don't forget to turn your stuff in.